All right, we start with the first page of the project. Probably most people have done this, but I will still show you something interesting. Okay, over here. So firstly, this software is called Sage Math. It's stronger than your ordinary matrix calculator, because I believe some of you guys tried to do the REF in the calculator, but it turns out giving the wrong answer. Okay, and I'll briefly explain why, and then show you that we do have some mathematical capable computing softwares that can deal with finite field. Okay, so firstly, we are copying the, let's start with problem one. Okay, problem one is a linear system solving thing. So the standard process is to copy the augmented matrix, right? So let me do it here. So this is the augmented matrix in the linear system. Okay, then this is basically copy from the paper, right? Most people will do the REF, right? It turns out to be a form with fraction. Okay, let me point out that this thing is actually wrong. Why this is wrong? That's because this is the correct thing over R. Okay, R, in my case, I'm doing it over rationals, but that doesn't matter. Okay, so the problem asks us to do the REF or do the arithmetics over F5. Okay, this is a finite field. So this guy has a different arithmetics than the rational number or than the real number or the rational numbers. Okay, first of all. So what's the correct way to do that? I will firstly show you the answer and explain why. So you are never going to see fractions. So the correct way, I mean, declare we are doing a finite field here. That only works in the Sage Math file. I think I am able to share this with you after next Monday, because it does contain the correct answers, which I am not allowed to share before you guys submit the project. Okay, so we are going to input the matrix and then print the matrix. All right, you already see here we have some difference here, right? So it is not printing the same matrix as can there not be negative numbers either? Max, that's a good point. Yes, exactly. So you can see I'm asking my Sage to print the matrix, but it's printing a different matrix than I give him, right? So you can say -2 is automatically converted to 3. Okay, so basically I'm copying a bunch of numbers and then I require there should be 3 rows. So, you know, that should be clear, right? So then 2 is okay. 2 is copied as 2, but the -1 is copied as 4. So that's weird, right? But in the F5, so you can think we are representing numbers in base 5. So roughly speaking, in the decimal numbers, we represent the number in base 10, right? And then in the binary system, we represent a number in base 2. So here we are doing base 5, meaning that every number A, I want it to be represented by A mod 5. Okay, what does A mod 5 mean? It means, for example, I have 7. Okay, then 7 is 5 times 1 plus 2, right? So you're basically doing division with remainders. Okay, then 7 should be represented as a 2. Okay, similarly, if I have negative 2, all right, then that thing is 5 times negative 1, right? My pen is not writing well here, but it's 5 times negative 1 plus 3, right? The point is the remainder is 3. I'm trying to write a 3, but yeah. Okay, anyway, I think now we are clear what the matrix is, right? We should start with this matrix. Okay, then another thing is, how do we do the REF? Well, if we do like A1 REF, we just did, that's the wrong answer. Okay, let's see what the AREF is. We are never going to say fractions. That's the correct answer. Okay, first of all. Then how do we get this answer? I mean, we cannot always ask a computer to do that, right? So we should be able to do it by hand. Okay, let me show you the process. All right, so any questions so far? So we are going to do the first step of REF. Okay, we start with this matrix. So then the correct thing to do is row 3 minus 3 row 1, right? Okay, then what we should have for the first place is definitely 0. Okay, then for the second place, we have 2 minus 3 times 1, which is negative 1. But we shouldn't have a negative 1 here. All the numbers we have there should be either 0 or 1, 2, 3, 4, right? So then negative 1, we take the remainder, that should be 4. Okay, sorry, my pen is not writing well. Okay, so then the third place is 4 minus 2 times 3, which is negative 2. So negative 2 in our word should be 3, right? And then the last one, 4 minus 4 times 3, which is negative 8. But converted to F5, mod 5, that should be 2, right? So then we find that after the first row reduction, our third row becomes the same as the second row. Okay, that's why we have a redundant row here, all being zeros. Okay, then you guys do the second row operation and the rest. Okay, you are going to say this is the correct answer. So, any questions so far? Okay, I'm going to clear everything and move on to the next one. So the next one, we are not going to spend much time. So firstly, I input a matrix. Oh, by the way, you guys don't need to know the coding. Okay, just know the math by hand. That's an easy computation probably for the second one. So then I print the matrix. So that's basically copied from the worksheet, right? So then I do a REF. Okay, that's the correct REF. Not done yet. So we are supposed to find a base for the kernel and the image. So I guess for those who attend the Tuesday class, this shouldn't be a problem for you, right? So basically, the 2 pivot columns correspond to the image columns, right? So basically, the base of the image should